In this video, I'll go over the mathematical models that we'll be using for one-dimensional kinematics. So to start, we have displacement. So displacement, we call delta x. So this triangle, that's the Greek letter delta, and it means change in. Okay? So displacement is the change in x, where x is a position. So delta x is change in position, which is also called displacement. So displacement is delta x. And that's equal to xf. So x again is a position. The f means final. Final position, and then the I on the other one means initial. So displacement is final position minus initial position. Velocity. X here, x means in the x direction. Normally, the x direction is going to be horizontal. While we're doing one-dimensional kinematics, sometimes we'll be looking vertical, and we'll sometimes call that the y direction. So velocity in the x direction, AVG. AVG means average. So this will give you the average velocity over some period of time. So the average velocity over some period of time is delta x, so that's the displacement or change in position, divided by delta t, change in time. And this is also equal to 1/2 times the velocity, the initial velocity in the x direction, plus the final velocity in the x direction. This equation is not always true. Remember, these are mathematical models, and there are times when they're not valid. Something that's particularly important to remember is these are only true for constant acceleration. I gave examples before that if you look really, really small or something moving really, really fast, these equations don't work. Most of these equations don't work unless you're in a situation with constant acceleration. If the acceleration changes at any point in the question, this doesn't work. If it's one period of acceleration when you're doing one thing and then you switch to some other acceleration, you can use this to solve it like two different problems. So when the acceleration is one value, you solve that, and then it switches to another value, you can solve it again. So you may have to break problems up into pieces to get this to work, and it won't work at all if its acceleration is not constant. Acceleration, again, I've said average acceleration, but I put average in parentheses because if acceleration is constant, then the acceleration at all times will have to be the average acceleration. So acceleration A, so that's acceleration, is change in velocity in the x direction. This is all 1D, so this is all the x direction. Acceleration in the x direction is change in velocity in the x direction divided by the change in time. And that is also equal to, so change in velocity, that's the final velocity minus the initial velocity over change in time. Okay. So that's displacement, velocity, acceleration. Speed. So your average speed is d. D is the path length that something travels. So that's different than delta x, right? Delta x means I only care what the starting and final positions were. D means I care about how you got there. Did I walk back and forth 15 times? Then I would count my d as 15 times back and forth. I would count my displacement as nothing if I start in the same spot. So your average speed is distance over change in time. If you're clever about putting all of these equations together, you can rearrange them into this. Okay? I'm not going to go through doing that. But this is also a description of your final position based on x0. x0, that is the initial position for time equals 0. So if I make the initial time start at 0, then that makes these equations easier to do. So x0, or x0, x final is wherever you started, plus your average velocity times the time, plus 1/2 the average acceleration times the time squared. So this will give you the position at any point in time t, whatever that final position will be after that t. Also, this is a handy equation because all of these, for velocity and acceleration and speed, involve t. And sometimes you don't have the t. Sometimes you only have the distances, the positions, or the speeds and acceleration. So if you don't have t, and you're not looking for t, then this one is a helpful way to do it. Again, this can be rearranged from all of the other equations. So this says the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the change in position. So that's how to use these equations. And you decide which ones you're going to use based on what you know and what you don't know. So you find the equations that can get you from knowns to unknowns.